Department of Energy taps Australian firm to explore Philippines' hydrogen potential. The Department of Energy (DOE) and Australian-based research firm Star Scientific Ltd inked an agreement to study hydrogen as a possible source of power for the country's energy needs. In a press release on Friday, the DOE said it had signed the Memorandum of Understanding (MOU) with Star Scientific Ltd. Star Scientific is known for its patented Hydrogen Energy Release Optimizer (HERO) technology, which converts hydrogen into heat without burning. The MOU allows the Philippine government and the Australian firm to partner up in studying on how using hydrogen power could help the Philippines achieve energy independence and significantly reduce the country's carbon dioxide emissions. The DOE and Star Scientific will work together to find ways that would allow the latter's HERO technology to convert existing power facilities into unlimited zero-emission hydrogen assets and increase the viability of distributing emission-free power through a supercritical carbon dioxide grid network, among others. We are hoping to be able to utilize hydrogen as fuel for electric vehicles and as part of the country's future energy mix. Energy Secretary Alfonso G. Cusi, who was one of the signatories of the MOU, was quoted as saying. He added that there was a vast potential for hydrogen power in the country, reiterating that it was considered as the fuel of the future. On Star Scientific's website, the firm's global group chairman Andrew Horvath said he was proud that an Australian innovation, the HERO, had captured the attention of a national government. This agreement with the Department of Energy of the Republic of the Philippines represents a significant milestone in the development of the global hydrogen economy, he was quoted as saying. This will represent the largest single boost to Australia's role in developing the global hydrogen economy, heralding a new era of research, development and deployment in the manufacture and installation of all parts of the hydrogen supply chain. We are particularly grateful and excited to be part of the next phase of the Philippines' economic growth, he added. DOE data showed that coal comprised 44.5% of the country's power mix in 2015, followed by natural gas at 22.9% and geothermal at 13.4%. At present, hydrogen is not part of the country's generation mix. With MOU, Cusi aims to harness the hydrogen resources of the country as fuel for electric vehicles and as part of the country's energy mix. This is in line with DOE's vision to make the Philippines energy independent and significantly cut the country's carbon dioxide (CO2) emission. Star Scientific's breakthrough technology is the Hydrogen Energy Release Optimizer (HERO), which converts hydrogen into heat without combustion. Under the MOU, the parties will study hydrogen production in the Philippines, explore ways to convert existing power assets using the HERO to unlimited zero-emission hydrogen assets, study the viability of increased distribution of emission-free power by way of a supercritical CO2 grid network powered by HERO technology, and desalination options for both existing and new systems throughout the Philippines through the use of the HERO technology. The Department of Energy (DOE) is furthering its push for hydrogen energy with the signing of another non-legally binding accord with Tokyo-based Hydrogen Technology Incorporated, HTI. The Memorandum of Understanding (MOU), signed between the DOE and HTI, involves exploring the use of hydrogen as a fuel for power generation. Under the deal signed on Wednesday, both parties will investigate hydrogen production in the Philippines to make the country energy independent and significantly reduce the country's carbon dioxide emissions. Energy Secretary Alfonso Cusi, in a statement issued on Thursday, said the agreement will fast-track its research and development (RAND) activities for hydrogen. The DOE, with the creation of the Hydrogen and Fusion Energy Committee (HFEC), commits to exploring hydrogen as a viable alternative and cleaner source of energy and its other beneficial applications for the Filipino people, said Cusi in his remarks during the virtual signing of the MOU. With the assistance of HTI and through the signing of the MOU, we are hopeful that the development of hydrogen energy will eventually be realized, he added. Cusi said he is hoping the Japanese company will be able to bring into the country its technology sooner to jumpstart RAND activities. I had been wanting to bring the model here in the Philippines so that we can do the trial usage of the technology in one of the islands. I hope that with the signing of this MOU, the model can be immediately shipped, he said. The energy chief further assured HTI the Energy Department will help facilitate the entry of its technicians, if necessary, given the restricted movements because of the current coronavirus disease 2019 pandemic. This is the second MOU the Energy Department signed to advance the study of hydrogen energy in line with the aspiration of including hydrogen in the country's future energy mix. In January this year, the agency signed a similar undertaking with Star Scientific Ltd, a research and development company based in Australia. Under the MOU, the government and Star Scientific will work together to find ways in which the latter's Hydrogen Energy Release Optimizer (HERO) technology can be used to convert existing power assets within the Philippines to unlimited zero-emissions hydrogen assets. Parties will also explore the viability of increased distribution of emission-free power by way of a supercritical carbon dioxide grid network powered by Hero technology, as well as desalination options for existing and new systems throughout the Philippines through the use of the technology. I have often said that there could be a lot of potential for hydrogen for the local industry given that it is seen as the fuel of the future, Cusi had said. Department of Energy Japan's HTI partner to explore hydrogen as fuel source for power generation. The Department of Energy (DOE) has partnered with Tokyo-based Hydrogen Technology Incorporated (HTI) to explore the potential use of hydrogen as a fuel source for power generation in the country. In a statement on Thursday, the DOE said Energy Secretary Alfonso Cusi and HTI President and CEO Yasuhiro Yamamoto signed a memorandum of understanding (MOU) on April 7 to fast-track the Philippines' research and development (RAND) activities for hydrogen. The DOE, with the creation of the Hydrogen and Fusion Energy Committee (HFEC), commits to exploring hydrogen as a viable alternative and cleaner source of energy and its other beneficial applications for the Filipino people, Cusi said. With the assistance of HTI and through the signing of the MOU, we are hopeful that the development of hydrogen energy will eventually be realized, he added. The MOU with HTI is the second accord that the DOE inked to further the research and development of hydrogen energy in line with the department's vision to include hydrogen in the country's future energy mix. Cusi noted that HTI will be able to bring its technology into the country sooner so that the RAND activities can already commence. I had been wanting to bring the model here in the Philippines so that we can do the trial usage of the technology in one of the islands. I hope that with the signing of this MOU, the model can be immediately shipped, he said. The energy chief told HTI that the DOE will help facilitate the entry of its technicians if needed, given the restricted movements because of the current COVID-19 pandemic. Under the MOU, the DOE and HTI plan to investigate hydrogen production in the Philippines to make the country energy independent and significantly reduce the country's CO2 emissions. Hydrogen is a clean fuel that, when consumed in a fuel cell, produces only water. Hydrogen can be produced from a variety of domestic resources, such as natural gas, nuclear power, biomass, and renewable power like solar and wind. These qualities make it an attractive fuel option for transportation and electricity generation applications. It can be used in cars, in houses, for portable power, and in many more applications. Hydrogen is an energy carrier that can be used to store, move, and deliver energy produced from other sources. Today, hydrogen fuel can be produced through several methods. The most common methods today are natural gas reforming, a thermal process, and electrolysis. Other methods include solar-driven and biological processes. Thermal processes. Thermal processes for hydrogen production typically involve steam reforming, a high-temperature process in which steam reacts with a hydrocarbon fuel to produce hydrogen. Many hydrocarbon fuels can be reformed to produce hydrogen, including natural gas, diesel, renewable liquid fuels, gasified coal, or gasified biomass. Today, about 95% of all hydrogen is produced from steam reforming of natural gas. Electrolytic processes. Water can be separated into oxygen and hydrogen through a process called electrolysis. Electrolytic processes take place in an electrolyzer, which functions much like a fuel cell in reverse. Instead of using the energy of a hydrogen molecule like a fuel cell does, an electrolyzer creates hydrogen from water molecules. Solar-driven processes. Solar-driven processes use light as the agent for hydrogen production. There are a few solar-driven processes, including photobiological, photoelectrochemical, and solar thermochemical. Photobiological processes use the natural photosynthetic activity of bacteria and green algae to produce hydrogen. Photoelectrochemical processes use specialized semiconductors to separate water into hydrogen and oxygen. Solar thermochemical hydrogen production uses concentrated solar power to drive water splitting reactions, often along with other species such as metal oxides. Biological processes. Biological processes use microbes such as bacteria and microalgae and can produce hydrogen through biological reactions. In microbial biomass conversion, the microbes break down organic matter like biomass or wastewater to produce hydrogen, while in photobiological processes the microbes use sunlight as the energy source. Learn more about biological hydrogen production from microbial biomass conversion and photobiological processes. Amid an international push to promote green hydrogen as a cost-competitive energy resource in lieu of fossil fuels, the Department of Energy (DOE) is tapping Australia-based research and development firm Star Scientific Ltd to look into the potential of this chemical element in the Philippines portfolio. Energy Secretary Alfonso Cusi said Manila, with support from Canberra, signed with Star Scientific a memorandum of understanding for the conduct of the project. I have often said that there could be a lot of potential for hydrogen for the local industry given that it is seen as the fuel of the future, Cusi said in a statement. Currently, green hydrogen that is produced with renewable energy-based electricity, is 2 to 3 times more expensive than blue hydrogen, which is produced with fossil fuel-based power. We are hoping to be able to utilize hydrogen as fuel for electric vehicles and as part of the country's future energy mix, he said, adding that another particular focus was hydrogen's potential role in power generation in the Philippines. Star Scientific is known for its breakthrough technology dubbed Hydrogen Energy Release Optimizer, HERO, which converts hydrogen into heat without combustion. The memorandum states that the DOE and STAR will investigate hydrogen production in the Philippines in an effort to make the country energy independent so as to significantly reduce the country's carbon dioxide emissions.